Hi, in this video I'm going to show you how to use XGBoost in R. XGBoost is a state-of-the-art machine learning algorithm known for its accuracy, for being better than neural networks or random forests. XGBoost is the main topic of my new course on Udemy, where we go end-to-end to really put in motion XGBoost, where we also do, for instance, hyperparameter tuning. So please be sure to check it out. The link is in the description. In this particular video, I'm going to show you the very basics out of it. We're going to solve a very simple case study on age prediction. And the idea is that we're going to predict whether people are above 18 or not. And this has very clear implications. Of course, you can say that from a business perspective, knowing people's ages or people age groups can help you better tailor the communication. As well, it can tell you where those people are. For me, the way that I see it, I'm going to call it the bouncer case study in honor of Berlin's most famous tourist activity, which is going clubbing, which is currently closed due to the corona crisis. And the way that we're going to do it, we're going to use a very interesting case study based on the Have You Ever game. So people were asked, have you ever, to a random bunch of questions. And based on this, we have the age groups, and we are going to predict whether they are above 18 or not. So the first thing that we need to do is to go to Kaggle. And in Google, we just search for Kaggle, and then we do Have You Ever. And it will be the first link over here. Next, if you have not done it, please don't forget to sign in. I'm going to do that with you as well. So sign in with Google, and then accounts. And then over here, we just click on download. And then we open the zip file. And then we click on the file, do Ctrl+C, and I'll just put it on my desktop. Here we go. It's here. And then next, we can now finally go back to R. And the first thing that we need to do is to set the working directory. So session, and then set working directory, choose directory, and then desktop, and then we just do open. And now it is very easy to import the data set. As a comment, always comment everything. And then in files, we have here the Have You Ever CSV. And let's go at it. So we are going to do dataset, and then we do arrow, we do read.csv, and inside we just include the file name, which is haveyouever.csv. Let's do Ctrl Enter. Now we just need to have a look at it. So we can see that first of all we have the age group, and then we have broken a bone, we have all these questions. So gone skydiving, been to Europe, driven a boat, been on water skis, been on a motorcycle, and then so on and so on. As well, also interesting or funny, had your cell phone ring at an embarrassing moment, paid for a stranger's meal, had a tooth pulled out, been pooped by a bird, had braces, all these things. And if we go back now to our script, there is one thing here that first we need to do. So we need to have a look at our data structure, and that is the first thing that I would like us to do. And so look at data structure. And in R, this is quite simple. There is str, which is a function, and then inside we just include dataset. Let's do Ctrl Enter. And we can increase here the size of our console. And if we put this to the right, now we can have a look. And there is a couple of things here. So the first one is that in the age group, it is as a character. We are going to need to change that. And the other thing is that all of our predictors are of a logical type. So we do need to change that because XGBoost does not accept it. So the first thing is that we're going to transform the dependent variable. And very simple, and we just need to do so. First of all, we go to our data set, and then we want to transform the age group. So we'll still keep it as that, and then we just do a if-else condition. And inside we go again to our data set, and then we do age group. Now, if this equals, and then in quotation marks 0 to 18, then I want a 1. And if not, I want a 0. Or better yet, so if it's 0 up until 18, I want a 0. And if not, I want a 1. Because our initial problem statement is to predict whether people are above 18, so that will be the 1. Next, as we have seen, we need to transform the logical into dummy variables. And what we are going to do now is that we are going to create a logical condition in which we are going to find whether the variables are logical or not. We're going to call this condition logical, and then arrow. We're going to use supply. Now, supply is something that enable us to create a check rule. So it's going to go through our data set, which is our object over here, and then is going to try to find whether things are logical. So is logical is what we want to find. And if I just run this part, so we have the logical over here. And again, if I do Control Enter just on logical, we can see that it looked at all of our data set and checked which variables were logical. And it checked it was almost all of them. Now, with this condition, all in all, now we're going to go through our data set. And if they are logical, then what we're going to do is that we're going to transform in numerical. So we want to transform them inside our data set, comma, and now we include logical over here. Because if we just run this, and I think it's easier if we just have a look at it, and here what we do see is that we'll see the 30 variables. So the first one that will be omitted would be the age group. So here our data set and then all the logical, this represents all the variables that are logical. And then we do arrow next. And what we want to do, we want to use the function lapply. So all in all, lapply and supply, they go hand in hand. So supply creates a logical condition, and then lapply uses this logical condition to make the transformation. And within lapply now, we go to our data set, and then we open the square brackets. Again, we do our logical. So this is what we want to change. And then we do comma, and here is the transformation. So as numeric. And if we just do this, and we go to our data set, we see that it has been transformed into zeros and ones. So let's return. Actually, one thing that I would like to mention here is that we have this NAs. And if we were using any normal algorithm, all in all, we would try to either remove the NAs or transform the NAs. But XGBoost is actually quite good at dealing with NAs, as it treats it as information. So we can just leave the NAs, and XGBoost will deal with that on its own. Next, now that we have transformed all of our variables, I think this one we have not transformed yet, so transform the dependent variable into zeros and ones. Now, the next step that we want to do is to transform our data set into a training and test set. And the goal here is that what we'll do is that within our training set, we'll create a model, and then we'll evaluate the model within our test set. And to kick it off, now there is one package that if you don't have it, please install it. So install packages, and then in quotes, CA tools. And then here we go. Next stop is that we're going to do set seed. And this is so that you have similar results as me. Next, now we actually want to retrieve the library. So in case you have CA tools, of course, you don't need to install it, but I have it. So I'm going to leave this one as a comment because I'm not going to run it. So set seed and then library CA tools. Next, we want to create a split rule. And what this means is that CA tools is going to split our data set into a ratio that we'll define. I'm going to do an 80-20 ratio, and it's going to do some kind of random split. And the function that we need to use is sample split. And then we go to our data set and then $ age group. And then finally we do the split ratio. I'm going to do 0.8. And if we just run split, just so that you have a look at to what it is, we can see that there are true and falses, and the trues will go to our training set and the false will go to our test set. And this will be completely random. And since we did the set seed, I think we'll have similar results as me. Now we'll create our training set and now arrow, and we do subset. And inside we go again to our data set, and here we just do our rule. So split equals true. And this is how we are going to subset our data set. Here we go, Control Enter, and it has 80% of all the observations. And to make it simple for the test set, we go to our training set and we copy paste, and then we just do test set. And let's do Control Enter again. This was a bit too hasty from my side because I should have replaced true by false. Here we go. We have the 556 plus the 2224. This will be 2780. Next step that we want to do, we want to isolate the X and the Y variable. We start off with the Y variable, so isolate Y variable. And to do this, we're going to call it, the first one will be train.y. And then as well, of course, since we created train.y, we'll also have to create a test.y. We go to our training set, $, and then age group. And then we do our test.y. Then arrow, we go to our test set, and then $ as well, age group. Let's run both of them. Here we go, we see our test and our train. The next step that we want to do is to isolate the X variable as a command, isolate X variable. And again, very simple. So train.x and then as well test.x. Let's do arrow and let's see what we need to do. So we start off by transforming it as a matrix. This is one of the requirements to use XGBoost, that the input predictors are in the matrix form. And what we want to do, we want to go to our training set, and here we can do it in two different ways. So we open the square brackets and we can do 2, because if we have a look at our training set, it starts with the age group, and we really don't want the age group. We want starting with the broken bone. So we start with 2. We can do up until 31. This for sure would have worked. And in fact, if we run this, we can see that our train X has run. But you can also do it differently. You can do it a bit more dynamic. So end call of our training set. And if by chance you decide to remove some variables, this would make it dynamic, so we don't need to change the number over here. And here we go, it is the exact same thing. And now to make it simple, let's copy paste this part and paste it below, and then change the training to test set. And let's just run this part again. So test set is done. Next one, we're going to state the parameters. And we are going to go with the very basic one. So state parameters. And inside we're going to call it parameters and then arrow. We're going to do a list and then we kick off the parameters. So we start off with ETA. ETA equals 0.3. ETA is a learning rate. So how fast do we want our model to learn? Next one, max depth. So max depth is all about the complexity of our tree, of how big we want our tree to be. Of course, these values, or max depth and ETA, they are connected in a way. If we have a very complex tree, we don't want our model to learn that fast. So one goes more or less opposite of the other. And I think the standard one is 6 for max depth. Next one, we're going to go with subsample. And this is very simply the share of observations that we want our XGBoost to have. Overall, XGBoost does not look at all observations at once. That is what makes XGBoost an ensemble algorithm. So it is the grouping or the junction of many models. Next is call sample by tree. And what we want to do here is not only does XGBoost not look at all observations, it also does not look at all predictors. And this really helps at dealing with possible multicollinearity, and of course by disentangle the factors and as well the impact. So column sample by tree equals 1. Next is mean child weight, and this one is very related to the subsample. Whereas in subsample we're looking at the share of observations, in minimum child weight, we look at the weight of the observations, because in XGBoost, not all observations are treated equal. So observations that are more difficult to predict, they have a higher weight within the model. And this makes total sense. The default value for this one is 1. And then we want to go with gamma, which is 0. And gamma is all about whether our model is conservative or not. We are doing a tree-based algorithm. Overall, tree-based yields better results when it comes to XGBoost. And a tree, or a decision tree, in fact, it splits as it grows and it becomes more complex. And if we want our model to be very conservative, the tree will not split as easily. And if we want our model to not be conservative, then it will split quite easily. Next, as well, set.seed, and as you've guessed it, it will be 1502. Then we are doing a classification problem, so our eval metric. So this one will be AUC. So area under the curve, this is a performance metric for classification problems, and it tells us how good is our model in differentiating between the true positive rate and the false positive rate. Next, we need to tell it, because we are doing a classification problem, but there are many types of classification problems. So we need to tell it that we're doing a binary. So colon logistic. And lastly, we need to tell it that we're doing a tree-based algorithm. So booster equals GB3. So let's have just a quick check. So we have a list, we have the ETA, max depth, subsample, call sample by tree, minimum child weight, gamma, set seed, eval metric, objective, booster. There's also commas everywhere. So this seems to be fine. And we can just do Control Enter. Next, we are actually finally ready to run XGBoost. And what we need to do here, so first thing is install packages, and then inside XGBoost. And I already have it, so I'm going to leave this one as a comment. And I'm just going to use the command library to retrieve XGBoost. And here we go. Let's do Control Enter. And we're going to create our model. And for this, we're going to go to our XGBoost. Then we do open parenthesis. we need to start off with the data. So data equals train.x. If we do, for instance, F1, just to have a look at what is XGBoost, let's just increase this size. There's params, data, and rounds. There is as well verbose, and there are many things that we can use. I'm just going to go with the very basic ones. So there's data, which is our train X. Next, it is the label. So this is our dependent variable, which is the train.y. And then we're going to do again set.seed again. So we're going to do 1502. Next, what we want to do, we're going to do n round, and we're just going to do like 50. This should be enough. Next, we need to state our params. So params equals parameters. And then finally verbose. So this is just so that our model communicates to us what it's doing as it is evaluating and running. So verbose equals 1. Let's just do Control Enter to run. You can see that it was quite fast. Our train AUC, so area under the curve, it is really high, so above 90. This probably means that we are overfitting. And if we were to do the hyperparameter tuning, for sure the ATA would definitely be lower. Next, we want to evaluate the results of our model. Evaluate model. And the way to do this is that we're going to predict. So predictions equal. We're going to use the function predict. And we're going to use our model to predict. And we need to include new data. So new data equals test.x. And if we have a look at our predictions here, or in fact, if we even run it, we can see that it is more or less a continuous value between 0 and 1. And of course, you cannot be 80% above 18 years old. So this is not working. So we're going to transform the predictions that we have just created. And we're going to do an if-else condition. So if-else. Now, if predictions, if this is bigger than 0.5, why 0.5? 0.5 is a value that maximizes the area under the curve. And if this is above 0.5, I want a 1. And if not, I want a 0. Next, we want to check the accuracy. This is where we compare the results of our model with what actually happened. And we're going to use a new library for this. So install packages, and then in quotation marks, Carré. I already have it. So again, I'm going to leave this one as a comment, and then just use the function library, Carré. Next, we now want to run. So we're going to use the function confusion matrix, and we need to create a table out of our predictions on the one hand, and these predictions will be compared to our actual values, which is the test.y. And if we just do Control Enter, we can see in our console, let's increase it. And we can see that we have roughly an accuracy of 78%. But what I would highlight is that we do have a lot of people above 18. So if we check out our test.y, we have 406 plus 38. So this is almost 450 people above 18, whereas we just have a little over 100. So I would say that since in our case study, our focus is to predict whether someone is above 18, because what we do need to have in consideration is that as a bouncer of a club, the people that you cannot allow to come in are the ones below 18. As a result, we need to have a look at this site. So the metric that we should look at would not be accuracy, but rather the sensitivity. And what does this mean? It means that within all people that are below 18, we are just good at identifying 29% of them. We're very good at identifying the ones above 18, so specificity above 91, but since our main goal is to not let the people below 18 to come in. So this is the most important one, is that we need to make sure that our sensitivity is high. And in that regard, we are not doing a very good job. So as for next steps, what we should do would be to really tune the parameters to really improve our model. But that is a very long journey that we're not going to do. And the thing that we can do now is, since XGBoost or overall machine learning is not only good at prediction, but as well can also be good at prescription. What we're going to look at most important drivers. And for that, we're going to use the SHAP values. So SHAP values is something that we can use in order to make our machine learning model a bit more explanatory, to really give us guidance to what matters most and in which direction. Very simply, we use xgb.plot.shap. It is really quite visual. So data equals, and then we go to our test.x, and then we do model equals model. And then we're going to look at the top 5. What does this mean is that we're using an have you ever. So if you are a club bouncer, or whether you care about predicting age, we can use these 5 questions, and this would be the best at predicting whether people are above 18. And of course, the first one would be gotten a speeding ticket. It is likely that if you live in Europe, you can only overall, drive a car if you're above 18. So this makes total sense. Of course, you can drive a bike if you are 16 or maybe even younger, I think. So gotten stitches, had a tooth pulled out, been to Europe, held a butterfly in your hand. So these will be the top 5 questions that you should ask in order to see whether someone is above 18. To make sure that it is easy on you, we are doing classification problems. So we just have evaluations here that are in the 0 over here, and as well in 1. So they are just zeros and ones. And as for the SHAP values, so above 0, greater likelihood, below 0, a lesser likelihood. And all in all, when it comes to the values of the SHAP, they don't have an interpretation per se. This is it for this video. If you're interested in knowing more about XGBoost and the implementation, and as well to know a bit more about the intuition behind it, please be sure to check out the Udemy link in the description below. I have as well other videos on my YouTube channel, so please be sure to check it out, and as well to subscribe to the channel. This has been an absolute pleasure, and I wish you a very wonderful day. And until then, have fun.